Hey everybody, this is Mr. Piercy. What we're going to be looking at in this video are concepts and properties about deductive reasoning. So previously in another video we've discussed what inductive reasoning is, where inductive reasoning is based on patterns that using those patterns you write statements called conjectures to therefore, test a conjecture and maybe make a prediction about how things are going to look later on, whether it's a numerical sequence or a symbolic sequence. Deductive reasoning is going to be slightly different. It's going to be using facts and definitions of, things that we know certain characteristics about. So for instance, we could, based off of prior instruction, prior knowledge, we could probably have some things based off about isosceles triangles, where I know that two sides are the same. We could then use that information to draw some conclusions that we couldn't necessarily just assume were to be true. Okay. Now, here, there's two specific things associated with uh, deductive reasoning here, and they're called the laws of logic. And the two particular ones that we talk about are the law of detachment and the law of syllogism. Well, the law of detachment, as you see here, it says if the hypothesis of a true conditional statement is true, then the conclusion is also true. So an example of something like that is, what I have up here in the top left corner of our screen. If the hypothesis isn't true, then the conclusion is true. So the hypothesis of our conditional statement says if Maria saves $2,000, then she'll buy a car. And so Maria has saved $2,500. So that means that we can conclude that Maria will buy a car. That's an example of what the law of detachment is. The law of syllogism is going to be a little bit different. And off here to the right side, let me pick a different color here so not all the red blends together. Here we're talking about what the law of syllogism really is. I know inside of the box it's giving you some, it's a very mathy explanation. It doesn't really explain what the law of syllogism is, in my opinion. So that's why I'm giving you the text on the right. Essentially what the law of syllogism is, and it's sometimes called its chain rule because, I'm trying not to get ahead of myself here. Law of syllogism relies on the fact that the hypothesis and the conclusion, or the conclusion of one statement, has to become the hypothesis of another statement. So we have that kind of connection where the end of one statement is the beginning of another. That's why they call it the chain rule, because they're linked together that way. So what they're explaining in this right here is that connection. And the way that they're writing it out, it says, if the hypothesis, then the conclusion. Well, whatever this conclusion is, it becomes the hypothesis of a new conditional statement. Well, based off of that, we could take whatever the original hypothesis was and this new conclusion to create a final statement. Okay? You could say something along the lines like, well, if it is Tuesday, then Mr. Piercy will wear a tie to work. If Mr. Piercy wears a tie to work, then he's going to look nice. So the conclusion, so what we can take off of those two conditional statements is that if it is Tuesday, then Mr. Piercy will look nice at work. Okay, not that I don't know. Maybe I don't look nice at work. Maybe I do. Maybe I don't. I don't know. And the last thing that I'm kind of giving you here at the bottom, on the left is kind of like what the math way of explaining what the law of syllogism is, where we say P with the arrow to Q. And the way that we read that in English is we say P implies Q. So we say, first of all, P implies Q. our hypothesis and conclusion. And then we can read as Q implies R. And the little dot 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 thing, the little triangle dots there, we read that as therefore P implies R, meaning that again the conclusion of one statement is the hypothesis of another statement, which allows me to kind of eliminate those and go straight from, instead of going from point A to point B to point C, we can go from point A straight to point C. Now here, moving on, we're going to take a look at some examples of what the law of detachment is, so that way we can make some conclusions. So in example A, if two angles have the same measure, then they are congruent. You know that the measurement of angle A is equal to the measurement of angle B. So they're telling you that A and B are the same. So because the measurement of those two angles satisfies a true conditional statement, the conclusion must also be true. So the conclusion that we can draw here is that angle A must be congruent to angle B. Next, we got Jesse goes to the gym every weekday. Today is Monday. So if we were going to look at that statement as a conditional statement, we would be looking at the hypothesis and the conclusion, saying that if it is a weekday, then Jesse goes to the gym. So accepting that that's a true conditional statement, that if it is a weekday, then Jesse goes to the gym. If I say now that today is Monday, the conclusion, using the law of detachment, is that Jesse will go to the gym today. Now here is where we're getting into looking at the law of syllogism. Now remember, the law of syllogism relies on the fact that the conclusion of one statement and the hypothesis of another statement have to match. They don't necessarily have to be in one order or another. As long as the hypothesis of one statement and the conclusion of another statement match, we can apply the law of syllogism to it. So looking at example A, if Ron eats lunch today, then he will eat a sandwich. So there's our first conditional statement. If Ron eats a sandwich, then he will drink a glass of milk. So looking here, the conclusion of the first statement and the hypothesis, let me pick another color, the hypothesis of the second statement match. Because they match, that is going to allow me, again, to kind of bypass the middle, and using the hypothesis here and the conclusion here, we can now make a new statement that says, if Ron eats lunch today, then he will drink a glass of milk. Now, moving on to example B. So let's see, let's go back to the blue here. In one statement, we have a conditional statement that says if x squared is greater than 36, then x squared is greater than 30. And we also have another conditional statement that says if x is greater than 6, then x squared is greater than 36. Well, here, because the conclusion of this statement and the hypothesis of this statement match, that allows me at this point to recognize I can now take this hypothesis and this conclusion and create a new statement based off of that. And down here at the bottom, for part B, that's exactly what we're seeing. That says if x is greater than 6, then x squared is greater than 30. Now, looking at the last example in C, we have, again, two conditional statements. The first conditional statement says if a triangle is equilateral, then all of its sides are congruent. So there is one conclusion. So the hypothesis of the next one says if a triangle is equilateral, then all of the angles of the interior of the triangle are congruent. Well, in both statements, neither statement has the hypothesis of one and the conclusion of another matching the same way that it did in example B and C, or A and C, A and B rather. Sorry. So in this case, because neither statement's conclusion match the other statement's hypothesis, we can't use the law of syllogism to create a new conditional statement. So go ahead and pause the video here and answer question 1 and 2 about the law of syllogism and the law of detachment. And once you have your answers, go ahead and hit play again and come back and see how your answers compare with mine. Okay, so in example 1, or checkpoint question 1, we have a compound inequality that says the measurement of angle A is greater than 0 degrees and it's less than 90 degrees. Then A is acute. So the measure of the angle A is 38 degrees. Using the law of detachment, what statement can you draw? Well, based on what we see here, because we have a true hypothesis of the conditional statement, we're able to draw the conclusion that that the conclusion is also true. So that means the statement that follows it, the angle A is 38 degrees, we can conclude that angle A must be an acute angle. Now for question 2, it's asking us which law of logic would we use, the detachment or syllogism. So we have a couple of conditional statements. If you do your homework, then you can watch TV. If you watch TV, then you can watch your favorite show. So what I'm noticing is that this conclusion and this hypothesis match. Because those two things match, I can now say I'm going to take this hypothesis and this conclusion and create a new statement that says the law of logic that's illustrated is the law of syllogism, because the conclusion of one statement is the hypothesis of the other statement. So that is how we're looking at identifying the difference between law of detachment and law of syllogism. Now here, I'm going to be up front. This one's going to be a little bit of a struggle, I think, for some of us to understand. And I tried setting it up in a way that I hope will help clarify some things as we go through it. So what we have in the example says, what conclusion can you make about the sum of an odd integer and an odd integer? Well, based on what we did in inductive reasoning, we wanted to see, is there a pattern? So we're going to test it. We're going to just pick several sets of odd numbers and add them together. So -3 and 5 give me an even number, -1 and 5, and so on. All of these wind up giving me an even number of some kind. So the conjecture is that the sum of two odd integers equals an even integer. Now remember, an integer is just a positive or a negative whole number. Well, now we have to try and test it. Now, filling this in and trying to just read it from top to bottom, I think is going to be a little bit challenging. So I've included some other things here that I hope will help make things a little bit smoother to go or to follow along with. So they're saying, let the variable n and m each be some integer. Now, using deductive reasoning, we want to try and prove that the conjecture is true. Well, at this point here, where it says 2n and 2m are something, we're going to say 2n and 2m are even integers. Because anytime I multiply something by 2, I'm always going to wind up with an even number. So that's just that's an accepted fact. No matter what number I have, I'm going to if I multiply it by 2, I'm going to wind up with an even number. So that means whatever the product of 2 times n and 2 times n are, those have to be even numbers. Well, what the conjecture that we're testing is, what are the sum of two odd numbers? So in order for me to take those even numbers and turn them into odd numbers, I can add and subtract 1 from either of those two things. If I subtract 1 from the 2n, I'm going to wind up with an odd number. And if I add 1 to the 2m, I'm also going to add up with an odd number. Okay? Because remember, we've already established that 2n and 2m are even. No matter what n and m happen to be, if I double something, I'm going to wind up with an even number. So if I subtract 1 from an even number, or if I add 1 to an even number, I wind up with an odd number. So that's just the property of addition that we're looking at there. Now, what we're going to be taking a look at So now we've established that 2n minus 1 and 2m plus 1 are they're going to be two odd numbers. And since the conjecture is saying the sum of two odd numbers is an even number, we're going to add our two expressions together. So that's why I'm saying 2n minus 1 plus 2m plus 1, because that's what we're testing. We're testing the fact that one odd integer plus another odd integer has to equal an even integer. Well, at this point here, we can combine our like terms. In the expressions that we have, 2n minus 1 and 2m plus 1, we can combine those things together. So the positive 1 and the negative 1 wind up canceling out, and I'm left with 2n plus 2m. And at that point, we can factor out the 2 and get 2 times n plus m. So the result here is the product of 2 and an integer, whatever number n plus m happens to be. Whatever that number happens to be, I'm still going to multiply it by 2. And anytime I multiply something by 2, we've already established that's a given fact that when I multiply a number by 2, I'm still going to wind up with an even number. So I'm really hoping I did a good job of sorting this out, because I know when I looked at all of the fill in the blank stuff for step 2, even me, I was a little confused with what they were looking at here, but I hope I tried clearing it up a little bit. But if you have any questions, please let me know. All right, so go ahead and pause the video at this point, try answering question 3 here, and when you're ready, hit play again and come back and see how your work looks with mine. All right. So it's saying use inductive reasoning to make a conjecture about the sum of a negative number and itself. So just like what we did in the last example, I want to test it. Okay, so I'm going to test it. I'm picking just some negative number, a negative integer, and itself would give me these numbers. Negative 1 plus negative 1 is negative 2, and so on. Those are just the numbers I picked. So now I'm going to use deductive reasoning, kind of like what we saw in the last example, to see how are we going to prove that it's true. Well, negative n plus negative n is the same thing as saying negative 2 times n. So the sum of a negative integer in itself is twice the value of the integer, which kind of proves what the conjecture was saying in the first place. So that's how I decided to try and answer that question. Hopefully you have something similar to the conclusion that I have, but it doesn't have to be verbatim what I have. Now here we're going to be looking at reasoning from a graph. And this is something that you've probably done some in Algebra 1, where you had to kind of look and see, well, what does this mean and what does that mean? So here we have an average running speed for some people over time. The runner's average speed decreases as time is spent running for part A, and the runner's average speed is slower when running for 40 minutes and running for 10 minutes. Well, what do we know here? The solution here is that based off of part A, we can say we're relying on a pattern to be able to make that statement, so I'm using inductive reasoning. For part B, what I'm doing is I'm using deductive reasoning because I'm comparing that with known information, with known values of some kind. It's not necessarily that we're looking at a pattern where we're using information, some facts to help us draw those conclusions. And lastly here, go ahead and again pause the video one more time, answer questions 4 and 5, and when you're done, go ahead and come back and hit play and see what your answers look and compare them with mine. Okay, so question 4, using inductive reasoning, write another statement about the graph in example 4. Now here, this is just an example. This is just a sample answer. This is not something that is the only answer that you could have. So my sample answer is, the faster the average speed of the runner, the less time he or she is running. And using deductive reasoning, again, this is just a sample answer. This is not the only thing that you could say. The runner's average speed is faster when running for 10 minutes than when running for 40 minutes. So those are just a couple of examples that you could have used to answer those questions. But that's going to bring us to the end of this lesson. Remember, Law or deductive reasoning is going to be using facts, information, accepted truths, something like that, to be able to draw conclusions about things that we can't just assume are true. And we have two laws of logic, the law of detachment and the law of syllogism, and how we can use those to draw conclusions using the law of detachment and write new conditional statements using the law of syllogism. At this point, guys, if you have any questions, by all means, let me know what they are. I'll be happy to help you with whatever questions that you have. But until next time, ladies and gentlemen, thanks for watching and take care.